Kia ora koutou. This video has question 4 of the excellence questions from this year's complex numbers assignment. This is one where we are given that z is any non-zero complex number, and we're told that z plus 1 over z is equal to k, and k is real. So in here, we're implicitly assuming that both x and y are real numbers, right? This is a complex number. And it's not that x can't be equal to 0, it's that we can't have both of them being equal to 0. So z is not equal to 0 plus 0i, right? But we could have z is equal to 0 plus 5i, or z is equal to 5 plus 0i. So that would be okay, and that would also be okay. It's just that we can't have both x and y being 0. All right, so usually when I do a question like this, I start by substituting in with x plus iy, or I do that reasonably quickly. And in this case, I did a couple of steps first before I did that, but you could have substituted in right from the start. So we've got z plus 1 over z is equal to k. I got a common denominator, z squared plus 1 is equal to k. Now I multiplied through and got z squared plus 1 equals kz. And you can see that we've got a quadratic coming. So I'll get this into a normal quadratic form first. And now I'll substitute in x plus iy squared minus k times x plus iy plus 1 is equal to 0. And that 0 means 0 plus 0i. The next step is to expand on the left-hand side. So I get x squared minus y squared plus 2xyi minus kx minus kyi plus 1 is equal to 0 plus 0i. Now I'm going to match up the real part with the 0 and then do the same for the imaginary part. So x squared minus y squared minus kx plus 1 is equal to 0. I'm not loving this, so I'm hoping that the next bit's going to be more useful. And 2xy minus ky is equal to 0. So that's matching up the imaginary parts. Cleaning this up gives me y into 2x minus k is equal to 0. So either y is equal to 0 or 2x is equal to k. And we're asked to show that either y is equal to 0 or this is true. So we've found that either y is 0. Now we have to show this last part, that x squared plus y squared equals 1. So taking this, if 2x is equal to k, we're going to substitute this in up here, and we'll get x squared minus y squared minus 2x times x plus 1 is equal to 0. That gives me x squared minus y squared minus 2x squared plus 1 is equal to 0. Negative x squared minus y squared is equal to negative 1. Timesing it all through by negative 1 gives me x squared plus y squared equals 1 as required. Or what we had before, that y equals 0. So we've got that or that, and that's what we had to show. Right, let's look at the second part of the question. So we had to show now that if we've got the situation where y is 0, then k is greater than or equal to 2. Now, in here, we're told, let's get rid of that. We're told right at the start that k is a real number, right? So what we're showing here is that either k is 2 or more or negative 2 or less. We don't have to let k equal a plus bi, right? So one more time, we were told that k is real. So what that means I can do is I can go back to where? I can go all the way back to here. And here's y. Let's go right back to the start. So we've got z plus 1 over z is equal to k. And we've got this time y is equal to 0. So z is equal to x plus 0i which is just x. So in here we have x plus 1 over x is equal to k, x squared plus 1 minus kx equals 0. Now I'm going to solve that by completing the square. I have x minus k over 2 squared plus 1 minus k squared on 4 is equal to 0. If you're watching this and you're not comfortable with completing the square and you're trying to do excellence questions for complex numbers, you have to get confident with completing the square. So go find my level 2 video on completing the square or someone else's or some textbook work. Right, now we're down to this. X minus k over 2 squared is equal to k squared on 4, take away 1, which is k squared minus 4 over 4. So x minus k on 2 is equal to plus or minus this. So x is equal to k on 2 plus or minus the square root of k squared on 4 over 2. But we know that x is a real number, right? We know that x is a real number because right back at the start, we were told that z is any non-zero complex number, right? If x is not real, then this hasn't been simplified far enough, right? So whenever we have this, we're assuming that x and y are both just the coefficient of the real bit and the coefficient, if you want to think about it as a coefficient, of the imaginary bit, right? For example, if we have z is equal to 3 plus 5i, x is 3, and y is 5. If we had 3 plus 2i plus 5i, we would be wanting to regroup this in here. So how does that help? Well, it means that I know that in here, I can't have any I stuff under that square root, right? So that means that we must have k squared minus 4 being greater than or equal to 0. And if you just sketch that quickly, we get our little parabola here. So if this is k and this is negative 4, we know that the solutions to that inequality are k greater than or equal to 2 or k is less than or equal to negative 2, which is the same as saying that the absolute value of k is greater than or equal to 2 as required. Okay, if you're in 13 MCA, that question was pretty well done. Both parts of it. There were a few people who didn't substitute in x equals iy, and then you came a little bit unstuck, but otherwise nice work on that question. Thanks for watching. I'll do question 5, 6 and 7 later today.